Hi, I'm Dave Brady. I want to show you something kind of cool. We have a spin-out company of our imaging program at Duke called Aqueti that makes array cameras. So originally at Duke we made gig-pixel array cameras. Aqueti's scaled back a little bit. They're making 100 megapixel array cameras. This Mantis camera, that's what's shown here. Each Mantis camera has 19 micro cameras. One's a wide field camera, 3.5 millimeter focal length lens that captures wide field scene, and then 18 narrow field cameras, each 25 millimeters in focal length. Each one has about a 60 microradian IFOV, so about 5x human vision. It's stitched in real time, but the 100 megapixel video is more than you can see on any normal display. So we create what we call a render server. That's a feed that goes to an individual user where they can zoom out and see the wide field, and then zoom in and see see the 100 megapixel resolution, but rendered on a low resolution display, so they have the feeling of an interactive space that they can explore. Typically, that's deployed with a direct connection from the cameras or an array of cameras to the render server. But the render server can also be on the cloud, which allows people anywhere to log in from any computer they have, or even portable devices, and interact with the media. So, for example, there's some media from one of our cameras that's online on Amazon Web Services at this site, 52.2.188.164. When you open that up, you come into the QView interface. So wait for that to open. It's going to ask for a login, and the password is very simple: 123456778. After you're logged in, you see that two cameras have been configured for this server. And there's some stored media from each of the cameras online. We're going to look at the data from this camera 65. If I go over here to the three bars at the right and click on the reservations tab, there's something that says Drones Descends. That's media that was recorded in Spain last March. And here that media has come online. So you can see the wide field image that was recorded at this site in Spain. You see the clouds moving, media streaming. We can stop time and make the clouds go backwards by clicking on the forward scan, or just let time run. And under here you see the trees blowing in the breeze. Zoom back out, pan around the image. Over on the hilltop here, there's a person that's just summited the hill, and his friend coming down through the bushes next to him. It turns out that there's a drone in the sky in this video. So if we go and click over here, we can find the drone, and we see a bird flying behind the drone. So again, this drone is a kilometer or so away, so the resolution we have on it is not enormous. I mean, we stop time and just on the drone and the bird. But the camera is able to find it over quite a wide field. What we're thinking of doing, what's really going to make a big difference, is the ability to combine array cameras with a diversity of other sensors. One of the sensors that we're particularly interested in developing, that's a very large opportunity, is this reference-free phase retrieval arrays, which will allow us to increase the resolution very dramatically from what we have for the array cameras. In fact, this camera is limited to just this 25 millimeter focal length, about a 1 centimeter entrance aperture, operating at f2.5, with the reference-free holographic systems, with the reference-free phase retrieval system. We can get to 10 centimeters or more, which will be give us resolution that will be 5 to 10 times higher than what we have with the Mantis cameras. When we use those arrays together in combination with neural image integration algorithms, we can create color, high-resolution images informed by 3D sensing from the LiDAR. So we see some very major opportunities for some revolutionary imaging systems.